Hi, back to Cook YouTube again. What I'm going to do today is I'm going to talk about basic circuit analysis, and I already have my document, and I already post on my website. Sorry, to the link. Just like this one here. Sorry, I'm this mistake here. Okay, what I'm going to do is that I'm going to use the p-space to analyze, the circuit, as well as, do hand calculation. And just to keep in mind that I'm going to use both p-space and hand calculation, to compare, and just to make it easier to be able to analyze, the circuit. In front of you here, it's just very simple circuit. You have the source voltage, 75 volt, connect to many resistors. Some of them are in series and some of them in parallel. And then we're going to compare the result from p-space with my lecture note here. Even it looks like the very simple circuit, but I will give you a guideline, to be able to analyze more complicated circuit later on. So it's good. It's going to be a good basic idea. What I'm going to do is that I'm going to refresh you a bit about our basic circuit. Then we're going to apply Kirchhoff voltage law and Kirchhoff circuit law, or in the short KVL and KCl. And that means you need to set up equation and to solve for unknowns, which is in this term is our current and voltage drop across each resistor. And then to be able to make sure that you set up the right equation, otherwise you're going to waste your time if you set up the wrong equation, because you have to solve equation altogether. And in this case, in the circuit, you have like 4 unknowns, which are I1, I2, I3, and I4. And then we go to compare the result to from the p-space. And also when you have 5 equations, I'm going to use the matrix to solve equation, and I believe that many of you probably forget about that already. So this is one of the technique to help you to solve more complicated circuit, and many people ignore this kind of technique to solve for some unknown, which is be able to apply to something else as well. Okay, let's get it started with the basic circuit here. I'm going to start with p-space first. I have the DC source voltage 75 volt, and just to refresh all that some already forgot to use p-space, I'm going to do something very quick to draw the circuit. First, you need to get the DC source voltage, or DC supply voltage. You simply go to draw menu, and then go to get new part, or you can just hit Control G, and you're looking for the DC source voltage. You simply type VDC, and then you place it on your schematic. Control G, you type R to get resistor, and you can rotate the resistor around by just Control R. And then you cannot have circuit without ground, and this one is the AG and D. that represent ground. And then also you want to connect resistor together, you need wire. You go to draw menu, you can see your control W here, you can draw the wiring. Okay, so this is just simple how to draw the circuit. And after you save the circuit, you can simulate. Go to F11, and if there's nothing wrong with your circuit, you're gonna show up current just right here. And then to display current flowing through each resistor and also voltage drop across each resistor, you simply go to the main menu, analysis, and you go to display result, enable voltage display, and you go to enable current display. So what you have here is you have the source voltage 75 volt, and you can see that the voltage difference between this point and this point, or the voltage drop across 30 ohm resistor, is 75 volt, the same as the source voltage. And that shows you the current 2.5 amp flowing through 30 ohm resistor, and here you have 7.5 amp current flowing, and also here you have like 5 amps current flowing through 4 ohm resistor and 3 ohm resistor, and also you have 1 amp current flowing through 40 ohms resistor, and also 4 amp current flowing through 10 ohms resistor. And you have the voltage difference between this point and this point, or the voltage across 40 ohms resistor and the voltage across 10 ohm resistor to be 10 ohms. And you can take a look at this one. You have 75 volt here, and then you are going to have the voltage drop across 30 ohm resistor. That's to be 75 volt, just like this one. You simply multiply 30 by 2.5 amp, and that's give you 75 volt. And now you take a look at this one here. You have 5 amp current flowing through 4 ohm resistor and 3 ohm resistor, and that means you have the voltage drop across 4 ohm resistor to be 5 multiplied by 4 is 20 volt. And you start from 75 volt here, you have 20 volt voltage drop across 4 ohms resistor. That's why you have the voltage at this point to be 75 minus 20, and that's give you 55 volt. And from this point to this point, the voltage drop across 3 ohm resistor. You have the 5 amps current flowing through 3 ohm resistor, and that means you have a voltage drop across 3 ohm resistor to be 5 multiplied by 3, and that's give you 15. So you subtract 15 from 55, this give you 40. So it's worked out very nice. Now the next step is that you go to my lecture note here. You can see let's analyze the circuit. Just recall the basic idea about how to analyze the circuit. When you have two resistors in parallel, that means you have the voltage drop across R1 and R2. They are equal, right? Because they connect to the same point. That's why we call it's connect in parallel. And if you have the current flowing through R1 and R2, which might be different or be the same if R1 and R2 are equal. Now in series, you're going to have the same current flowing through resistor R1 and resistor R2, and the voltage drop across R1 and R2 are different, or can be the same if R1 and R2 are the same. Now take a look at the circuit. What I have here is the source voltage 75 volt, and I put the node number 1 here, I put the node number 2, number 3, and number 4, just for references. Now you take a look at the voltage difference between the node number 1 and node number 4. You can see that 30 ohm resistor is connected in parallel with the source voltage. So the voltage difference between node 1 and node 4 is going to be 75 volt as the same as supply voltage. And in that case, you can calculate for the current equal to V over R, which is equal to 75 divided by 3. That's give you 2.5 amp, and that's going to be the current flowing through a 30 ohm resistor. And now you take a look at node number 4 and number 3. They all connect to the ground, so they have the same voltage or equal to 0. And now we voltage difference between the node number 1 and number 3. You can take a look at this one here. The node number 1 is connected to the positive side of the supply voltage, and node number 3 is connected to the ground of the supply voltage. So the voltage difference between the node number 1 and number 3 is going to be 75 volt. And that's why I have 75 volt here. And you redraw the circuit here. You have 4 ohms, you have 3 ohms, and you have a 40 ohm in parallel with the 10 ohm resistor. And next step, you want to calculate the current flowing through 4 ohms and 3 ohm resistor, and also the current flowing through 40 ohm resistor and 10 ohm resistor here. So what I did is just specify R total of 40 ohms resistor in parallel with 10 ohm resistor, and that means you multiply 40 by 10 and then divide by 40 plus 10, and that's give you 8 ohms. And then you add that up, with the 7 ohms, because they are in series, you're going to end up 7 plus 8. That's give you 15 ohms. And now you can find the current flowing through 7 ohms or 4 ohms and 3 ohm resistor. So your current equal to V over R, or equal to 75 volt divided by 15, and that's give you 5 amps, just like you have in your PSpice here. This is the 5 amps, correct? And now the next step, you need to find the current flowing through 40 ohm resistor and 10 ohm resistor. And from PSpice it show you 1 amp and 4 amp. Now you go to 40 ohm resistor and 10 ohm resistor right here. You can do many ways to find the current, but I take a look at this point, 75 volt, and you have 5 amp current flowing through a 4 ohm resistor and 3 ohm resistor, right? And that means you have the voltage drop across, let's say 7 ohms here. You simply multiply 7 by 5, right? That's give you 35 volt. So you can find the voltage different across 40 ohm resistor and 10 ohm resistor, right? Which is the same. Simply you subtract 35 by 47 75 volt, right? Let's give you 40 volt. So that's mean the voltage drop across 40 ohm resistor and 10 ohm resistor is going to be what? 40 volt, right? When you know the voltage difference or the voltage drop across each resistor, which are in parallel, you can find the current flowing through 40 ohms, right? Equal to 40 divided by 40 ohms, and that's give you 1 amp. And also for the current flowing through 10 ohm resistor, right? It's going to be 40 divided by 10, and that's give you 4 amp, right? And this one have a higher current flowing through 10 ohm resistor than the current flowing through 40 ohm resistor, right? Because this is a higher resistance. And when you add them up, you have the incoming current 5 amp, right? And it's split to be 4 amp and 1 amp. When you add them up, it's going to be outgoing current, which is agree with the KCl. This is how you analyze the circuit. Or I will point out, another technique which is will be more useful later on when you work with the more complicated circuit. I would call this one as the current divider. Well, you have an incoming current 5 amp, right? I want to find the current flowing through a 40 ohm resistor. I simply multiply 5 amp by the other resistor, which is in this case is 10 ohms, and you divide by 40 plus 10, and that's give you 1 amp. It's the same thing just like we worked out before, right? You have 1 amp current flowing through resistor, 40 ohm resistor, right? 1 amp. And this one is we worked out before. This is like 4 amp, right? To get a 4 amps by hand calculation, you multiply 5 amp by the other resistor, that's 40 ohms, and divide by 40 plus 10, and that's give you 4 amp. And that's what I call the current divider, which is different than the voltage divider. You're probably familiar with this already. If you have the source voltage to be 75 volt and you have 7 ohm resistor in series with two resistors which are in parallel, 40 ohms and 10 ohms, resistor, or our total is equal to 8 ohm. You can find voltage drop across 8 ohm resistor or voltage drop 40 ohm resistor and 10 ohm resistor by multiply the source voltage, which is in this case is 75 volt, by 8 ohm itself, which is different than current, and divide by 7 plus 8, right? You have 7 and 8, and that's give you 40 volt, which is agree with that's what we worked out before, because you have this one is 40 volt, and you have leftover current drop across 7 ohm resistor to be 75 minus 40, and that's give you 35 volt. Okay, so this is we call a voltage divider, which is very useful, so please keep that in mind. Well, when you have resistor in parallel, in this case I have 4 ohms and 4 ohms, they are equal. You're going to have our total to be half of what you have here, so it's become 2 ohms, and then the current will flow the same current flowing to resistor. In this case, it's going to drop to be half of the current or half of the incoming current. And if you have n resistor in parallel and they are the same value, your current is probably seen to be I over n, where n is number of resistor in series, in parallel. Now let's do KVL and KCl, right? For KCl, you know that the way we do is just we are talking about coming in current equal to total flowing out current. And you take a look at the node 1 here. You have incoming current to be I and outgoing current to be I1 and I2. So your I equal to I1 plus I2. And for KVL, you have the voltage drop across the loop is equal to 0. You consider the current in the direction of clockwise. You're going to have the voltage, the source voltage, equal to the voltage drop across this R, which is equal to IR. So this is it depends how many R you have. You have to add them up together and take into account the direction of the current flow that you were defined at the first place of the circuit, which you will see later on. Now back to the circuit. If I specify the current at this point to be I1 here, I2 here, I3 here, I4 here, and that means you have 5 unknowns, right? And you require 5 equations to be able to solve for all current. and in that case, after that you can find the voltage drop across each resistor, because you know how much the current flowing into that resistor. Now take a look at when you apply KCl at node number 1, you have a summation I coming in current is going to be total outgoing current. Consider the node number 1, you can see incoming current is I and outgoing current is I1 and then plus I2. And now take a look at the node number 2. You have a incoming current is become I1 and outgoing current is I3 plus I4. That gives you equation number 2. Now consider the apply KVL. You take a look at the loop number 1. Right here you have V equal to 30 ohms multiplied by the current flowing through it. So this is, I have I2 here. And the loop number 2, you can take a look at this one. If you specify the current direction like this, you're going to have I1 is flowing in the direction of clockwise. You have 4 multiplied by I1 and then plus 3 multiplied by I1, right? It's going to be plus also I4 multiplied by 40 and then equal to I2 multiplied by 30. Now for equation number 5, you can also see here the current flowing to 10 ohm resistor is I4, right? So you have a 10 I4. It's going to be equal to what? I'm sorry, I have I3 here flowing to 10 ohm resistor, and also have I4 flowing to 40 ohms resistor. So you're going to end up with the 10 I3 equal to 40 I4, just like I have right here. And what I want to point out, just like when you want to set up equation, sometimes you waste your time because you set up the wrong equation. And when you have the wrong equation, of course you're going to have the wrong result. That means in this term you're going to have wrong I1, I2, I3, I4. So that's why I mentioned about a piece price here. You can check it, if you have the right equation or not. What I mean is just like you take a look at your circuit, which have the current and the voltage drop across each resistor already. So the best way before you solve equation, just like practice, make sure you get the right equation. Let's take a look at the equation number 1 here. You have R equal to I1 plus I2 from the circuit. What is your I1? What is your I? Your I is right here, 7.5 amp, right? And you have I1 equal to what? This is your I1, or the current flowing through 4 ohms resistor, or 5 amp, and then you have 2.5 amp. So 5 plus 2.5, that's give you 7.5. That's correct. And also the node number 2, you have I1 equal to I3 plus I4. What is your I1? I1 is 5 amps, right? What is your I3? It's 4 amps. What is your I4? It's 1 amp. So you add them up. You have 5 equal to 5 amp. For KVL, you can see that let's move to equation number 4 here. You have 4I1 plus 3I1 plus 40I4 equal to 30I2. What is your I1? Your I1 is what? 5 amp, right? 5 multiplied by 4 is give you 20. I1 is 5 plus multiplied by 3 give you 15. So 20 plus 15 is give you 55. What is your I4? I4 is 1 amp, right? So you have 35 plus 40 equal to I2 multiplied by 30 ohms or not. Your I2 is what? Your I2 is 2.5 amp. You multiply 2.5 amp by 30, that's give you 75 volt. So you got the right equation. Okay, so this is just want to point it out for you. Don't want you to waste your time, right? Because you're not only working on the simple circuit just like this, but later on you have to work on more complicated circuit. Now let's move on. So I rearrange all 5 equations. Just put all the current on the left side of equations and put the number on the right of equation. Now you probably understand how to analyze a simple circuit, but at this point I want to mention you about to solve equation using matrix, because we are dealing with many unknowns. So sometimes it's going to be more helpful to use matrix to solve equation for you. In this case, you're going looking for current I1, I2, I3, and I4. Okay, let's refresh a little bit about the matrix. The way to multiply matrix: if I have matrix A multiplied by matrix B, let's give you the result matrix C. You know that to be able to multiply matrix, for the first matrix you need a number of column equal to number of rows of the second matrix, and then the result matrix, you're going to end up with the dimension 2 by 1. In this case 2 is come from number of rows of the first matrix, and 1 is come from the number of column of the second matrix. Now to find you can get C11 and C21 from matrix A and matrix B. You simply multiply A11 by B11 and then plus A12 multiplied by B21. So end up, this is my C11. And C21, you multiply A21 by B11 plus A22 multiplied by B21. Okay. And now the way you solve for B, right? I have matrix B here. This one you have a matrix A multiplied by B equal to C, and if you want to find B, you multiply both on both sides of equation by A inverse. So A inverse multiplied by A gives you identity matrix, and I multiplied by B gives you B. It's come back to be the same. That's why we call identity matrix. And then you also multiply A inverse to the C and give you B. This is the way to solve equation using matrix. Now for our system, you need to set up our matrix equation. In this case, A multiplied by B equal to C, and you can solve for B. In this case, B is the current matrix. Now the way to set up equation, you need to take a look at equation. Let's see equation number 1. You have I minus I1 minus I2 equal to 0. Okay, I minus I1 minus I2 equal to 0. The way you multiply matrix, okay, you need I1. That's why I have 1 here, minus I minus I1. That's why I have minus 1 here. because you need to multiply -1 to I1, and also you have negative 1 here because you want equation I minus I1 minus I2, and that's equal to 0. Okay, this is the way how to set a matrix. Okay, let's take a look at the equation number 5. 10I3 minus 40I4 equal to 0. This is my last equation. Here you need to 10I3 minus 40I4 equal to 0, and you don't have I1 and I2, so that's why I put 0 here. Okay, hopefully you understand. Now to find B, I just multiply A inverse to matrix C. This is my inverse matrix, and thus I end up with this number here, and you multiply A inverse to C matrix, which you already have, and end up with this matrix. Finally, you know all the current. You have I equal to 7.5, which is correct. That's we did before. And then you have I1 become 5. This is your I1. And then I2 become 2.5. You have I3 become 4 amp, and then I4 is 1 amp, just like in your PSpice. Okay, so this is just show you some technique that many people ignore, but it's very useful. And I know it's not so easy for you to find your A inverse, especially you have like larger dimension of matrix. In this case, it's 5 by 5. Okay, we will continue to analyze more complicated circuit by using this idea in series 2 later on.